This isn't malware, and that is the problem. We found at least 30 skills in the ClawHub registry, which is really the NPM of AI agents, that secretly recruit your AI agent into a cryptocurrency swarm without you consenting to it. Just install one of these skills and everything happens on its own. So say you come across one of these 30 skills, all published by the same author. Once installed, the agent follows simple instructions in the skill.md text file, and it registers itself with onlyflies.buzz domain, which is associated with this activity. I don't even want to call this a campaign necessarily because it's not malicious. That is the whole hook behind what we found. So your agent registers itself to this external onlyflies.buzz network, generates private keys for a cryptocurrency wallet, hands them to the third-party server or person, and then starts working for someone else. How does that sound? This matters more than you think. It isn't just about the used CPU cycles and your resources being used for someone else's benefit, and not to mention the big compute bill you may end up with. What this finding is teaching us is that threat landscape has shifted. This could be the death of static analysis. You see, traditional tools, security tools such as static scanners, they look for malicious code or code that is doing something damaging, like deleting files on your system or exfiltrating secrets, sensitive files to an external server. What they cannot catch is your agent following simple instructions written in plain English or any natural language, and all it's doing is following these instructions and using the tools it is being instructed to do in natural language. How do you penalize that? How do you catch that? Then there's a theme of shadow workforce going on. As I said earlier, your AI agent is now effectively been recruited by another, maybe I can call it botnet, even though it's not malicious, but it's working for somebody else using your resources, which is problematic. And I think the biggest concern here is the trust gap. We are moving away from don't run suspicious executable files .exes to don't run this skill because you don't know what it may do at runtime. But I think this is an interesting crux because even skills that may look benign to a user or a machine, just statically, if you read it, it's just simple English instructions. On runtime, the context may evolve and they may end up doing something damaging. For example, during our research, we came across this skill called Derp on skills.sh registry. Now, Derp is interesting. There's no malicious code in it, no base64 encoding, nothing, no network calls or anything such. But it tells your coding agent to deliberately write broken code or introduce infinite loops, which on runtime will cost you resources and compute power. Oh, and it even tells your agent to sort of ignore its existence so that the agent doesn't flag that Derp is running. Very contradictory behaviors. And in this entire system that we found, the 30 skills recruiting your agent, data leakage is sort of inherent. Because for now, it's just registering your agent using simple fingerprinting information such as your host name and IP address. But what if the next update in any of these skills takes this a step further and requests something more sensitive? Because we have seen POCs in the past. Initially, they started off by simply collecting your fingerprinting information, like your host name, username, working directory name. But the later iterations, they even started peeking into your Etsy shadow, your bash history, environment variables, which are sensitive no-go areas. And finally, there's a loss of agency in effect going on here. Because right now, if your agent, just by a simple skill.md file, can register itself to an external party, what else could it do? Could it also start recruiting other AI agents into this network? This is what I'm saying. The whole game has changed and no one has the answers of what the next iteration of such a campaign could look like. And my favorite part here is that this isn't malicious. This isn't malware. There's no signs of damaging code in what we found. So no registry can actively penalize it. For example, a registry can actively take down code which is harming other users. Whereas ClawSwarm, it's first of all, it's based on a legitimate project. ClawSwarm is actually run by the Swarm Corporation. It's well documented open source project on GitHub. The SDK, everything is legitimate. What we found, the onlyflies.buzz implementation, that's just one implementation of this open source project, and it's been customized to do what it's doing, recruiting AI agents. Now, if you were to go back to the registry like ClawHub and ask them to remove this, Technically, this isn't a clear malicious versus clean case. This is more of a gray area. I'm not even sure if this is violating their terms of service, other than maybe skills like this could be seen as registry abuse or polluting registry. So you're trying to solve the problem at the registry layer or via static code scanning, but the actual problem is happening at runtime layer. And that can only be solved not with a patch, but visibility alone. So full disclosure, I am head of research at Manifold Security, and we specialize in runtime security for agentic AI. But the 30 ClawHub skills we talked about today, they are vendor agnostic. You could have employees in your corporate environment running these skills, and regardless of whether you have a solution or visibility into the runtime layer or not, you're certainly bound to be surprised with what may happen at runtime. And this is why I urge you to know not just what your agent is and what all is it running, but what happens the second it starts talking to other systems or connects externally to other servers. So I don't think this is a one-off. I'm pretty sure we'll come across several such examples in our research in the future. Thanks for watching this episode of Security Report. I'll see you in the next one.